Good evening, sir. Okay, so I'm okay as you say, sir. करना है? Done. Thank you. Good evening, everyone. Hello, good evening. Shall we start? Friends?
Yes, ma'am.
Fine. Thank you so much, Hari sir. So today is, I think, day 7, and I'm going to talk about the parametric test, right? So any idea anyone can tell me what do you mean by parametric test? Anyone? Yes. At least say yes or no, you are knowing something about this or not. Friends, Hari sir, do you know anything about parametric test?
Ma'am, you have said earlier that it is based on population parameters and also follows the rules of normal distribution.
Very good. Thank you so much. So I am sharing my screen. Tell me whether my screen is visible or not. Yeah, it's visible.
It's visible.
Fine. Okay. Fine. So we are starting with day 7 and with parametric test. So when we say parametric test, I think as Hari sir said already, I discussed, but still, parametric test generally we are using, or these tests are based on assumptions like normality, equal variance, etc. Right? These tests are based on the assumptions such as normality, equal variances, no outlier, etc. So this is about the parametric tests. Non-parametric tests are not considering any distribution, specifically the normal distribution of the data. But parametric tests are more concerned about the normal distribution of the data. Apart from that, these tests are also based on parameters of population. So parameters meaning is what? It is characteristics. Right? Characteristics here we can say like mean, standard deviation, proportion, etc. So this is about parametric test, right? Now, in this category, there are various tests comes like t-test, ANOVA, set test, regression, correlation, etc. Right? So these are some of the examples of parametric test. Today, the agenda is we are talking about t-test. So, what is t-test? T-test generally we are using. So, I'm writing the purpose. Purpose of t-test is to check or to test the So to measure the significant mean difference. This is the purpose of t-test. So whenever we want to compare the means, so other way around, if I want to say, we can write to compare mean. To compare means we are using t-test. Requirement is generally, or requirement mainly we can say, or we can say when to use. So first one is the purpose is when you want to check the significant mean difference. Second one is generally the sample size should be less than or equals to 30 and SD of population is unknown. These are the conditions. In these conditions, we are using the t-test. Right? Conditions are clear? Is it clear?
Yes, ma'am.
Fine. So this is the case. Now, talking about the types. Types of t-test. It is one sample and two samples t-test. When we say one sample, so when we say one sample t-test, here we can say, because as the purpose of t-test is to compare the means, right? But when I'm having a simple or single sample, because it is one sample, when I'm having a single sample, question comes how I can compare the mean. It is not possible, right? So firstly, I can say in this case, we will compare sample and population mean, right? So that means purpose will remain same. That is the comparing of the mean is possible in t-test. And in case of one sample t-test, we will compare the sample and population, right? Now, we can say in case of one sample t-test, we will be having single sample or single variable. Not or, I think and is appropriate. Single sample and single variable. Right? Now, we will be having single sample and single variable. Then we can say the variable requirement will be we need to have one variable and it will be numeric. That is continuous. Right? So this is about the one sample t-test. In case of one sample t-test, we are comparing the sample mean with the population mean or population mean with the sample mean. And we will be having only a single sample and single variable. Right? So in variable requirement is we need to have one variable or single variable, and the type of the variable should be numeric or continuous variable. Right? Now, talking about assumptions. So usually in statistics, almost every test is having certain assumptions. So what are the assumptions in case of one sample t-test? So the first says we need to have single continuous variable. Right? Second says this is known as your single context variable, just a minute, is known as your dependent variable, right? So we can say dv should be normally distributed. That should be, there should be no outlier or outliers in D. So these are the three main assumptions which you need to test when you're talking about one sample t-test. So this is a simple thing which I told you. I hope it is clear to everyone. Is it okay?
Yes, ma'am. Fine.
Now, I'll take one example and we'll see how we can perform one sample t-test in the R, right? So suppose we have IQ score of 15 people. Check whether the sample is, whether the sample belongs to the population having IQ or mean IQ as 100. Question is clear? What do we want to do? We want to see, suppose we are having a sample of 15 people and we have collected their IQ scores, right? We want to check whether the sample belongs to the population whose mean IQ is 100. Is it clear? So here I can write population mean can be hypothetical or known, right? Is it okay?
Yes, ma'am.
Fine. So you can find here the problem says we are having a known population mean. This is 100 is known. If this is not known, you need to take some assumption about your population mean. Only that way it is possible to compare. Fine. So now if I want to check, so firstly I'm making my hypothesis here. So my hypothesis will be there is no significant difference in the mean IQ score of sample and population. Then alternative hypothesis will say so this will be the alternative hypothesis that there is a significant difference in the mean IQ score of sample and population. Clear what I said? Is clear? Yes.
Yes, ma'am.
Fine. So we will move now and we will see that if this is my hypothesis, how I can perform the one sample t-test, right? So firstly, I need to create one vector. Vector of what? IQ score of 15 people, right? So I'm entering some values here. Let me check the length firstly. 15. Done. So, Hari sir, it is okay for you, or do I need to copy this vector into the chat?
No, ma'am, it's okay. I am just taking notes right now.
Fine. So I have written here the vector IQ 15 IQ scores I have stored here. These are, I have just assumed these figures, right? So length of IQ is 15. That is 15% IQ score I have stored here. Now, as I said, I need to perform t-test. Hypothesis we have already performed. Now, firstly, I want to check the assumptions, right? So my first assumption is the normality, because first assumption is, very first one is single categorical variable is required, right? And it should be the dependent variable. So you can see I have created one numeric variable. We can assume this is dependent variable. Now I need to check its normality. So for checking the normality, we are having methods like you can use the histogram. You can use the QQ plot. You can use the method like Shapiro-Wilks test. Right? Fine. Is it okay? Now, firstly, I will write the null hypothesis of normality, or of, I'll show you. Suppose I'll check firstly I'll make firstly the QQ plot. So I need to write QQ norm, and then I need to pass the name of my vector only. So I have written QQ norm, right? It is helping me to create a QQ. It is helping me to create a QQ plot, right? So you can see the QQ plot is generated at my fourth window. I want to fit a line. You can check. This is the fitted line, and almost most of the points or most of the IQ scores are roaming around the fitted line. That means there is no much deviation. That means we can say it is normally distributed, right? So according to the QQ plot visual, if I will say, I can say it is normally distributed, right? Fine. This is histogram. But if you will look at a histogram, you can see if you will put a bell-shaped curve on it, it is indicating your data is right skewed. So this is the second method. Third one is the Shapiro-Wilks. So for Shapiro-Wilks, I'm writing the null hypothesis. For this test, the null hypothesis says variable is normally distributed. Right? This is the null hypothesis of Shapiro-Wilks test. Now I need to perform Shapiro.test. This is the function. I need to write the name of my vector, which is IQ. Control Enter I'll press. You can see we are getting the results in the output or console window. So I'm copying the line here. Now you can see, as I think yesterday, or sorry, day before yesterday, I think we have seen the chi-square test, and I told you the p-value rule. So this is the p-value. I need to compare. Suppose I want to test the hypothesis at 5% level of significance. So I can say this is greater than 0.05. It is 0.06, which is greater than 0.05. So in this case, we need to accept the null hypothesis. And when I'm accepting the null hypothesis, it says variable is normally distributed, right? So I can say my variable, that is IQ score, is normally distributed. Done? Fine. Shall I go for next?
Please, can you repeat the uses of Shapiro test once again?
Yes, Shapiro-Wilks test is the test which we are using for testing or checking the normality of the variable. So for this, the null hypothesis says variable is normally distributed. So in our case, variable is what? It is IQ. So I can write IQ score is normally distributed. This is the null hypothesis of Shapiro-Wilks test. To perform this, we are using Shapiro.test function. Inside this, you need to only give the name of your vector. So once I perform, you can see this is the output coming in my console. I have copied this and pasted here. So I have seen the p-value, which is 0.06. I will compare this with the 5%, which is 0.05. So it is clearly indicating me that the p-value is greater than 0.05, that is 5%. So you need to accept the null hypothesis. So when you are accepting the null hypothesis, what you will conclude? You will say IQ score is normally distributed. Is it fine, sir?
Yes, ma'am. Fine. Thank you.
Yeah. Now, moving to the outliers checking. We need to check outliers in the data, that is in the IQ score. So for checking the outliers, the method name is box plot. Right? So for creating a box plot, you need to use the function called box plot, which is asking you your variable, that is your vector, and then main is we are using to give the title. So I think in the fourth window you can find I have made the I have created the box plot for the given IQ vector. Visible to everyone? So shall I go for interpretation?
Yes, ma'am.
Now you can see in R, although box plot is not that much appropriate in our case because the data which I have given you, it is assumed or is means we have arbitrarily taken the figures, right? So if you have seen box plot, actually in box plot, I'll tell you there are 5 elements. I'm writing the name of 5 elements here. So first one is the median. Median is what? You can see in the diagram, the middle line, the darker line, the solid line, the black line, you can see I'm rotating my mouse. This is the median value, right? Then you will be having quartile 1, quartile 3. So the box you can see, the gray color box. So the lower wall of this is known as the first quartile. And the upper wall of this is known as the, or the top wall of this is known as the third quartile, right? Then there is lower whisker and the upper whisker. So lower whisker is not coming in our graph, because in this particular data, the values are starting from 100, so that is a probably it is not created. But you can see the upper whisker is coming. This is the upper whisker, right? So these are the 5 elements of the box plot. Once you need to understand whether the outlier in your data or not, what you can see beyond the whiskers means this is the upper whisker. Same way you can get the lower whisker also if your data can produce that. In that case, if you will see beyond these whiskers, if any circles are coming, that is, this is the indication of outlier in the data. Is it clear? Presently, you can see beyond my upper whisker, no circle I am getting. That means there are no outliers in my data. Is it okay? It is fine?
Yes, ma'am.
So you can see we have checked all the assumptions of one sample t-test. That means we are good to go now to perform one sample t-test. So I'll tell you the function name is t.test. So what I did deliberately, I have written here t.test. Why so? Because I want to show you people the syntax of this. You can see it is visible to you. In the fourth window, you can see t.test x comma y null. Then alternatively two-sided less greater. That means whether you have performed or this test for the one tail test or two tail test, that you can define here. Then mu value will be whatever your mu that you can pass. If you are performing the dependent samples, you can make it paired, you can make it true. So likewise, you can see, and you can see the meaning of all these which are given here, right? So now I'll come here, I'll write t.test. My vector name is IQ and mu is 100. And that way I have run the line number 757. You can see at the console I am getting the output visible to everyone. I hope you can find. This is the values I am getting, which I am copying here, putting here, and then we will go for the interpretation. So the T statistic or T value is 4.1022, degrees of freedom of 14, because we are having 15 observations, so 15 IQ score, so 15 minus 1, it is 14. Then P value is coming as 0.001078. So as if I'll check, or if suppose I have told you to check the hypothesis at 5%, so you can compare with the 5%, you can find the p value which you are getting is less than 5%, which is 0.05. So this says you need to reject the null hypothesis. So now the t-test null hypothesis I am rejecting. So you can see I have written the hypothesis here. This was the hypothesis, so I am rejecting this. I'll go with the alternative hypothesis, and what I'll say, there is a significant difference in the mean IQ score of sample and population. That means I'm saying the difference is existing in the mean score. And if you will see, we can see the mean of X is coming as 102, right? And our sample, population mean was 100. That means sample mean is more than population mean. Is it clear?
Yes, ma'am, clear.
Fine. So this was one sample t-test. If it is okay and clear, shall I go for now the second kind of t-test, that is two samples. So shall I? Okay. So when I say two samples meaning you will be having two samples or groups, right? Again, purpose will be same, to compare mean. So when you want to compare mean of two samples, we will go for the two samples t-test. Now, there is the possibility the samples can be dependent or independent. So you need to see which type of samples are given here. So on the basis of this, two samples t-test can be bifurcated or divided. Hello? Yes. Hello, sorry for inconvenience. It was an important call. Fine. So I'm coming again. So I said two samples t-test can be further divided into independent samples t-test and dependent samples t-test, right? So we will compare the mean of dependent and independent sample, or we will compare the mean independent and independent samples. So firstly, I'll talk about independent samples t-test. So when I say independent samples t-test, again, we can say purpose is to compare mean in two independent samples. Right? Now, variable requirement. So if I talk about variable requirement, we can say we need to have one dependent variable which will be numeric or continuous, and one IB which will be categorical. Right? Now, talking about the assumptions. First one is DV should be continuous or numeric. IB should be categorical with two groups or samples, right? DV should be normally distributed in the groups of IV. Fourth says there should be no outliers in DV corresponding to the groups of IV. Last fifth says there should be equality, or there should be equal variance of DV in the groups of, or in the corresponding groups of I. So these are the 5 assumptions which you need to check when you're talking about the independent samples pretest, right? Now, suppose I want to compare condition I am writing, example. Assumptions are clear?
Yes, ma'am.
Fine. So I'm writing the example here. Suppose we want to compare mean marks of male and female students. So, as you can see, looking at the example, it is clear that we need to compare mean, right? So this is the purpose. Talking about the variables. Anyone who can tell me how many variables are there in this example? Yes? How many variables are there? Anyone? How many variables are there? Yes? Please try. Anyone? Okay, if you will look at the example, I think it is clear we are having marks and gender with 2 groups, male and female. Right? Is it clear now?
Yes, ma'am. Ma'am, is there 4 variables in total or only considering 2 variables?
Why 4, sir? I'm not getting how there are 4.
Since there are 2 different groups, so I think so.
So we are 2 groups, sir. So maybe we will means we can say we will be having the marks of male student. We will be having the marks of female students. So the 2 groups.
Okay, ma'am. Okay, ma'am. Got it.
Yeah. It is clear, right? So this is the case. Firstly, I will write my null hypothesis here. My null hypothesis will be there is no significant difference in the mean marks of male and female students. So this will be the null hypothesis which I have written, right? There is no significant difference in the mean marks of male and female students. Opposite to this, alternative hypothesis will be there is a significant difference in the mean marks of male and female students. So I'll copy and I'll make my alternative hypothesis also. Done. Fine. Okay.
Yes, ma'am.
Fine. Hypothesis created. Now we need to have data. So for the data, I'm creating two vectors, one for gender and second one is for the marks. Fine. So suppose I am writing gender and I use ref function. It will save my time. 10 is fine. Can anyone explain me what is the meaning of this line number 795? What it will do for me? Anyone?
10% in each group.
Very
That is-
good. Yes. Yeah. There are 10 males and 10 females, right? Now I need to create one more vector which will be of the marks. So I'm creating a vector using C function. Suppose the exam is out of 50 marks, right? So out of 50, I'm assuming some of the marks, right? So for example, I'll check length so that I can understand how many numbers have. It is 21. I'm removing anyone. It's 20 now. Done. Same length vector I have created. 20 observations I have taken in the gender. So for 20 students, 20 marks I need to have, or 20 students marks I need to have. So I created a vector with the length 20. It is okay?
Yes, ma'am.
Fine. Now, what I'll do, I will check the assumptions. First one is for the normality. Remaining two, I think clear. Gender is categorical variable with the two groups. Marks is the numeric variable, right? Other than that, I need to see whether the sample or whether the groups are independent or not. So I think it is quite clear. Male student will be the male student. He cannot be the part of female group. Similarly, female student cannot be the part of male group. That means from the one person, I need to collect data only once. So that way I can maintain this independency, right? So three assumptions we have checked by our own. You need to only observe and you need to see the assumptions, check the assumptions. Next assumptions we will check here using the various functions. So for normality, I think I already told you, we need to use QQ norm, right? And then I can fit the line also. So you can see it is almost indicating normality. Shapiro.wilks I am using here. Shapiro.test and I'll pass here the marks. You can see the p-value which we are getting at the console. Right? So looking at the p-value, can anyone help me to conclude what this p-value is saying to me? Do I need to accept or reject the null hypothesis of Shapiro-Wilks? Anyone?
Ma'am, it is less than level of significance. So we should reject the null hypothesis.
It is greater than, sir. It is
Yes, ma'am.
0.25.
Yes, ma'am. Greater than.
So we need to accept. If it is less than, in that case, we are rejecting. So you were correct. If it is less than, then reject. But it is greater than, so we will accept. Right?
Yes,
So
ma'am.
what
I
are,
was
yeah.
confused with 0.05 or 0.5.
Yeah, it's not 50%, it's 5%, right?
Yes, ma'am. Yes, ma'am.
So we can say marks is normally distributed, right? Now we need to check the equal variance. For equal variance, you need to use CARE function, sorry, CARE package. Okay. Okay, my mistake. Okay, loading is done because I already have this package. So that is why I have not run the line number 807. But if you are performing for the first time, you need to run the first line, this line first. And then I am loading all the packages of CAR into the global environment to use it, right? Now, there is a function called live test. I'll pass marks. I'll use tilde and I'll write gender. I'll write gender. Now you can see we are getting the output, right? Visible, I hope. The degrees of freedom, I think visible to everyone. It is 1. F value is 0.0629 and P value is 0.8048. So I think firstly I'm writing what will be the null hypothesis for Levin's test. So you can pay attention for Shapiro also you will be having a null hypothesis. For Levin test also you need to having a null hypothesis, and this test we have applied to check equal variance, right? Null hypothesis says variance of dV, that is marks, is equal, right? This is the null hypothesis. Looking at my p value, if I will say it is greater than 0.05, means I need to accept the null hypothesis of Levin's test. So what I'll conclude? I'll conclude variance is equal. And we are looking for the equal variance, which is coming equal. Done? Is it okay? Nobody is interacting, so I think I'm understanding that people are getting me. It is fine.
Excuse me, ma'am.
Yeah, ma'am.
I don't get the result here.
Which thing you not got?
I think from line number 810.
Line number 8,
810.
810.
Yes, ma'am.
So what you're not getting? The symbol you're not getting that?
I don't know, the answer is not getting it. Tilde is from,
It is on the second row of your keyboard. Where
yes, I got it, ma'am. I got it, ma'am. Marks tilde gender I returned,
Okay.
but I don't
Are you
know
not
how
getting
many.
the output?
No, ma'am, I don't get the output.
Any error is coming?
No, ma'am, one warning message. Let me check. Yes, ma'am, I got it. I
Got it?
think, Got it, ma'am. Got it.
Fine, fine, fine. Okay. So
Ma'am.
ma'am has got, if ma'am is performing, those who are not performing, I think they are only hearing or listening to me. So you can see the p-value is greater than 0.05. That says I need to accept my null hypothesis. So what I'll say, variance is equal here, right? Fine.
Yes, ma'am.
Fine. So two means four assumptions we have checked. We need to check now the outlier. For checking the outliers, we are using the box plot. Box plot for marks tilde, we need to use the gender. So we will create two box plot, one for male, one another for female. You can see now both side in both you can find at the fourth window, which is indicating me the plots, which is showing you that F, that is for female. This is the distribution of female. This is the distribution of male, female marks and male marks, right? You can find beyond the whiskers. This is the upper whisker in both the cases, and these are the lower whiskers in both the cases. So we are not getting any circle. It shows we are not, or data is not having, or marks is not having any outlier, right? That means all the assumptions of the data are met now, right? Okay.
Yes, ma'am. Okay.
Fine. That means assumptions are met. We are good to go. We are okay and all set for performing the t-test. So I'm writing here. So it is t dot test. We will use marks tilde gender. Now you can see at the console, I'm getting the output. I'll copy the line this, bring it or paste it here. Now you can see the t value is coming as minus 1.666. Degrees of freedom are 17.867, and the p value is coming as 0.2587. This is greater than 0.05. That means you need to accept your null hypothesis, right? Is it okay?
Yes, ma'am.
Fine. So once you will see this, it is indicating you need to accept the null hypothesis. You need to check the hypothesis of the t-test, which was this. So you will say there is no significant difference in the mean marks of male and female students, right? The difference is not significant in the marks. This is what we are concluding. I hope it is okay and clear to all. Friends, it is fine.
Yes, ma'am. Fine.
Okay. So it is about the second kind of t-test. Now we will go for performing the dependent samples t-test. So should I go? Everyone is okay, fine. Asna ma'am, done?
Yes, ma'am. Please proceed.
Yes,
Right.
ma'am.
Fine. So we will write here now the next category of t-test, that is dependent. So it is dependent samples t-test, right? So when I say dependent samples t-test, meaning is we need to compare. So we will compare mean in dependent groups. Now, what is the meaning of dependent groups? Possibility when the group will be dependent only when once you are collecting the data from the same samples. twice. So data collected should be for same group and twice. For example, I have collected the marks data for same group of students twice, right? So meaning is that, for example, I have, or suppose I have planned to teach some new topic to my class, right? So what I did, I started with a test, a quiz, right? Suppose I have circulated a test or quiz among my students. I have collected their score, and then after teaching the same topic to the students, again I have conducted the same test, right, on the same group of students. So that way I am having the score of the students. That is, dependency will be there, because for one student I collected the data twice. So there will be certain time gap, right? So when you are talking about dependent sample status, there will be some intervention. Intervention meaning is that, say for example, without, firstly when I conducted, there was no teaching I have done, but after that I have done a teaching and then I collected their score. So intervention is the teaching. Similarly, any companies, their company is planning to give training to the employees. So maybe before training their performance, after training their performance. So training will be then intervention, right? So there will be some intervention when you're talking about dependent sample status. Also, there should be time gap in data collection, right? So means, suppose today I collected the data, suppose 4 or 5 days I have taught to the students, and again I have collected the data from. So there will be some time gap in these two conducts. So this is about dependent sample status, right? So here the variable requirement will be you need to have one dependent variable, that is numeric, right? And for numerical continuous, and for this variable you will collect data 2 times, right? So now talking about the assumptions. There should be one dependent variable, that is numeric. Then the difference. Difference meaning is difference in score. So as I'm having the two scores, right, before, after, pre, post, etc. So in those scores, I need to take the difference. So the difference in scores should be normally distributed, right? And the difference, or there should be no outliers. There should be no outliers in difference of, or so these are the assumptions which we need to generally check to perform the t-test, right? Now, for example, a teacher wants to check whether the scores have improved of 10 students after teaching them. Right. So in this case, suppose I am creating two vectors before. So before teaching, what were the scores of the students? So suppose the test was conducted on out of 10, right? So I'm writing the few scores. How many I have written? 2, 4, 6, 5. There are 11 figures. 10. Now, after. Done. 10th of after. One more. Done. Is it okay? Done? Done?
Yes, ma'am.
Now, to check the assumptions, I need to firstly get the difference, right? It is before minus after. So we got the difference, right? Now we will check the normality. So we need to check the normality of difference. Done? Oh, I forgot. I need to make UQ line. Okay. Similarly, Shapiro dot test for difference. Yes. Anyone who can tell me the interpretation of this? Anyone?
Here
Hmm.
p value is less than 0.05.
Hmm. Yes. Hmm.
We should reject the null hypothesis.
Very good. So once I'll reject the null hypothesis of Shapiro-Wilk, what I'll say the difference of the score is not normally distributed. Then, fine.
Yes, ma'am.
Then, what I have done. Something wrong. I forgot to close some bracket somewhere. Yeah. Happened, yeah. Just a minute. This happens with R. Wait. I open a new script. Let's start from here. Yeah, it is fine now. So after I need to increase 1, made it 5. Fine. Coming 2 times. Moving it. Done. 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 Then done. Fine. Now we'll go for the box plot. Now you can see box plot is coming, and although as again the data is, we have taken arbitrary, so we are not getting the upper whisker, but we are not even getting the outlier because there is no circle we are getting. That means there is no outlier in the data. So now we can see we have checked all the assumptions. You need to now perform t.test. We will use here. This time you need to write the name, that is before, comma, after, comma, paired equal true. So you can see you are getting a output, right? I'm copying this. Control C, Control V. Anyone who can help me to interpret this?
Here p value is less than 0.05,
Hmm.
so we should reject null hypothesis.
Very good. So we will reject the null hypothesis of t-test, which I think I forgot to written. So I'm writing here, suppose my null hypothesis will be there is no significant difference in mean marks before and after teaching. So that means I need to reject this null hypothesis. So once I'll reject this, I'll conclude alternatively there is a significant difference in the mean marks before and after teaching, right? This is the meaning. Now we'll go or I think other way around also I'll say, if we are saying there is a significant difference, meaning is that you can check now, the mean difference is minus 2.4, or maybe you can check here. Okay, so it is showing you the mean difference. Mean difference is negative. So what we have passed before minus after. That means before mean is less than after mean, right? So that way, that means we can say after teaching, the mean score has increased, right? So we can say that teaching is effective, right? Or if you wish, you can do one thing, you can check the mean of before, also the mean of after. It is clearly visible. Before teaching, the mean was 3.1. After teaching, the mean is 5.5. And that way you can say that scores has improved after teaching. That means teaching is effective. Is it okay?
Yes, ma'am.
Fine. So this is about t-test. Now I have shared one file. I don't know how many of you are having R. Is it possible for you to do, or do I need to show you how to perform the t-test using the file I have given you? Yes.
Yes, ma'am. So was the process.
Okay. So I don't think so. Still, just a minute. I'll copy the path of my file, which I have provided to every one of you. Do set WD. If you can recall, I told you first you need to set the location. Location meaning is why we are doing setting the location, because we want to give instructions to R that what is the location of my file from where I need to pick the data. So I have done this. Now I'm using read.csv function. I'll write the name of my file, which is so this is the file, right? So either I think I can store it somewhere, maybe in this, right? Now you can see this is my data, right? What I need to do now, suppose I want to compare the satisfaction score on the basis of gender. This is my data, right? So what I need to do, I'll write my hypothesis. There is no difference in mean satisfaction score of male and female. Suppose respondents, right? Now, I already told you assumptions you can check. Suppose I'm checking Shapiro.test. So from data, for which variable I'll check? It is for the satisfaction score. So we can see these are the p values we are getting. So according to the p-value, if you will see it, you can say it is greater than 0.05. That means you will hold your null hypothesis, which says your satisfaction score is normally distributed. I hope it is clear.
Yes, ma'am. Clear.
Similarly, Levin test you are using for satisfaction score tilde data dollar gender. Okay, this is not approved. Fine, suppose I'm removing it. Error in the element test. I think previously we have done this, no? Same function we have used. Just data dollar gender. Okay, we'll do one thing. Data dollar gender. I'll convert this into the factor. Probably this will help us. Fine. Yeah, you can see as gender, if you can pay attention, just I'll cut this line here. As you can see, I'm showing you the data. In the data, you can find gender is coming as 1212. So that is why R is reading it as a numeric variable. So what I did, I converted it into the categorical data in the factor data, right? So that is why you can see it is now it is giving us the output. And if you will look at the p value, which is 0.5039, which is greater than 0.05, that means you will say variance is equal of the satisfaction score in the male and female respondent group, right? Now we will check the outlier. So for checking the outlier, I'll use the box plot function, and for the data dollar satisfaction score tilde data dollar gender. You can see two. I hope you can see the fourth window. You can find that we are getting the two box plots, and in the second box plot, suppose one is for the male. This is the male respondent satisfaction score, and this is the female respondent satisfaction score. Now you can see in the second box plot, you are getting one circle beyond the upper whisker. That means one outlier is available in your data. Is it clear? Fine, friends.
Yes, ma'am. There is outlier noticed in second one.
Yes. So now I think I'm not removing it although, but suppose I'm copying it so that, yeah. And then I'll perform the t-test. We are getting the output. You can see this is the output we are getting. Okay. So what will be the interpretation here? This is the p-value. What is the interpretation?
P-value is greater than level of significance.
Very good. So we need to accept the null hypothesis. So when you are accepting the null hypothesis, what you will conclude? You will conclude there is no significant difference in the mean satisfaction score of male and female respondents. Fine. Okay.
Yes, ma'am.
Fine. Now you are having the weight before and weight after data available with you. So if you wish, I'll show you. Do I need to go for that also dependent using the same data? What I'll do, I'll take the difference of data dollar weight before minus data dollar weight after. Done. Then sorry, where I performed, I don't know which sheet that was. Done. Done. Now I can go for Shapiro and we'll see the diff. What will be the conclusion of this output? Shapiro we are using for the normality. What is the conclusion?
P value is greater than level of significance, so we should accept the null hypothesis.
And what we will conclude if we are accepting it? Variable is normally distributed, right?
Yeah, yes, ma'am, right.
You can see the box plot is coming. We are not getting any circle beyond the whiskers. That means there are no outliers. Now you can perform T dot test. Here you need to write data dollar weight before comma data dollar weight after comma paired equal true. Done.
Yes, ma'am.
Okay, so looking at this,
No outlier here, ma'am.
yeah, but t-test I performed, sir. Now you can see we are getting the t results. So what will be
Yes, ma'am,
this?
yes.
What is the p value? What this will say? This is a very small figure. It is 2.2 e minus 16. It is 2.2 10 to the power minus 16. It is very small figure. That means it is less than 0.05. So you
Reject
need,
the null hypothesis.
yes, we will reject the null hypothesis. And when we are rejecting the null hypothesis, what we will say, there is a significant difference in mean weight before and after. Suppose after joining the gym or maybe opting any diet plan or something. So whatever the person has taken the intervention, that is the impactful, that is the effective. It is making change in the weight, right? Fine. Fine.
Yes, ma'am.
Fine. So this way, this was the t-test from my side for the day. Now I'm concluding the session. Today we have understood the three kind of t-tests: one sample, two samples, and in the two samples we have seen independent and dependent samples. So in case of one sample, you need to compare sample and population mean. Population mean can be the known to us, or we can hypothesize it, or we can assume it, right? And there were very simple assumptions you need to check: that normality and the outliers in case of one sample. When you talk about the independent samples, you need to firstly compare the means. So you will compare the mean of dependent variable into the two groups of the independent variable, right? So here you will be having one variable, one dependent, one independent variable you will be having. In the independent variable, there will be two categories, right? So assumptions here will be normality, main assumptions, normality, outlier, and the equal variances, right? T dot test function you can easily use here, and that way you can perform the independent samples t test. always you need to pay attention or keep in your mind there will be the null hypothesis for the Shapirovitz's test, also the Leven's test for checking the equality of variances, and then you will check the null hypothesis of the t-test, right? Then talking about the dependent samples t-test. So in case of dependent samples t-test, you will be having dependent samples. That means for the same group of people, you will collect data 2 times on a particular time interval, right? There will be certain time interval, some time gap will be there in the 2 conducts. And that way, you can compare the differences, whether the intervention is making any impact for whatever purpose you have used it. So that way, this is known as the dependent samples t-test. So it is all from my side for the day. Now the session is open for the questions and answers. If you are having any questions, you can ask me. If not, we will end the session for the day and meet next day tomorrow for the next session. Yeah. Any queries? Okay, no questions? Fine. If there are no questions, we are meeting tomorrow. Thank you, everyone. Yeah, Deepa ma'am, do you want to say something? Yeah, Hari sir, do you want to say something?
No, ma'am. Thank you for the session.
Okay, thank you. Fine. So if there are no queries, we are ending the session. Yoga sir, we are done for the day. Yoga sir?
Thank you, ma'am.
Thank you, Anjali ma'am. Yoga sir, we are done for the day. Are you there? Thank you, sir.